So I have already completed all the questions of Young modulus, and here we have the first questions of bulk modulus. And the question is, a solid sphere of radius 10 cm is subjected to a uniform pressure which is equal to 5 into 10 to the power 8 Newton per meter square. Determine the consequent change in volume. Bulk modulus of the material of the sphere is equal to 3.14 into 10 to the power 11 Newton per meter square. Okay. So we know that bulk modulus K is equal to volumetric stress upon volumetric strain, which is equal to P divided by delta V upon V. That means we can write PV divided by delta V. So from these questions we have to calculate the consequent change in volume. That means we have to calculate delta V, which is equal to PV divided by K. Now here in this question, some of the data are given, like P is given, which is 5 into 10 to the power 8 Newton per meter square. Then a bulk modulus K is given, which is 3.14 into 10 to the power 11 Newton per meter square. And radius of the solid sphere is given, which is 10 centimeter. And you have to convert that 10 centimeter into meters, because here all the data are in SI unit. So this would be 0.1 meter. Now we have to calculate V first. So volume of that solid sphere is 4/3 pi r cube, which is equal to 4/3 into 3.14 into 0.1 to the power cube. Now substitute all the values here in this equation. So P is 5 into 10 to the power 8, V is 4/3 3.14 into 0.1 to the power cube, K is 3.14 into 10 to the power 11, and we have 4/3 3 here. So 3.14, 3.14 will cancel out with each other, and after calculating this, the value would be 6.67 into 10 to the power minus 6 meter cube. So this is our answer. So the consequent change in volume is this 6.67 into 10 to the power minus 6 meter cube. Question number 2 is, find the change in volume which 1 meter cube of water will undergo when taken from the surface of the bottom of a lake 100 meter deep. Given volume elasticity of water is 22,000 atmosphere. Okay. Now first, the volume elasticity of water, this means that bulk modulus is given. So K is given, which is 22,000 atmosphere, that means ATM. Okay. Now first of all, you have to convert this ATM into Newton per meter square, which is the SI unit of bulk modulus. Okay. So first we are going to convert this, and 1 ATM is equal to 1.013 into 10 to the power 5 Newton per meter square. And we know that bulk modulus is equal to PV by delta V, which is volumetric stress upon volumetric strain. Now here in this question, V is given, which is 1 meter cube. Okay. Then height of the lake is given, so H is 100 meter deep. Okay. And here we have to calculate delta V. So delta V is equal to PV by K, right? Now see here, P, you have to calculate P first. Okay. So P is equal to H rho G, right? Now H is given. Rho means obviously here we are talking about water. So water density of water is 1000 kg per meter cube. And G we all know that acceleration due to gravity is 9.8 meter per second square. Okay. So just put all the values here and calculate P first. So this is equal to 9.8 into 10 to the power 5. So this would be Newton per meter square. So Newton per meter square. Now we have P here, we have V, we have K. Now put all the value in this equation. So delta V is equal to P is 9.8 into 10 to the power 5. V is 1 meter cube. Then K is 22,000 into 1.013 into 10 to the power 5. And after calculating this, we'll be getting 4.4 into 10 to the power minus 4 meter cube. So this is our answer. So the change in volume would be 4.4 into 10 to the power minus 4 meter cube. So here in this question, you might confused about this volume elasticity of water. So whenever we have this word volume in elasticity, that means they're talking about bulk modulus. Okay. Question number 3. A solid ball 300 centimeter in diameter is submerged in a lake at such a depth that the pressure exerted by water is 1 kgf centimeter inverse 2. Find the change in volume of the ball at the depth. K for material of the ball is 1 into 10 to the power 13 dyne per centimeter square. Okay, so you all know that K is equal to P divided by delta V upon V. So from here, delta V is equal to PV upon K. So the given data are K is given, which is 1 into 10 to the power 13 dyne per centimeter square. P is given, which is 1 kgf per centimeter square. Now see here, we have to convert that kgf per centimeter square into dyne per centimeter square because all the data are in CGS. So first from kgf to gram, so it would be 1000 gram f per centimeter square, and from here it would be 1000 into 980 dyne per centimeter square. Okay. Then another data that is given, which is diameter of the ball. So D is equal to 300 centimeter, and so the radius would be 300 divided by 2 is equal to 150 centimeter. And from here we can calculate the volume, which is 4/3 pi 150 cube centimeter cube, and just put all the values in this equation. So it would be first 1000 into 980 into 4/3 pi 150 whole cube divided by 1 into 10 to the power 13. And after calculating this, the value would be 1.385 centimeter cube. So this is our answer. So the change in volume of the ball at this depth would be 1.385 centimeter cube. Question number 4. A spherical ball contracts in volume by 0.0098 percentage when subjected to a pressure of 100 atm. Calculate its bulk modulus. Given 1 atm is equal to 1.01 into 10 to the power 5 Newton per meter square. Okay, so here it is said that the spherical ball contracts in volume by 0.0098 percentage. That means the change in volume is equal to 0.0098 percentage of the original volume, which is V. That means delta V by V is equal to 0.0098 divided by 100, right? And we know that bulk modulus A is equal to P divided by delta V by V. And here the pressure is equal to 100 atm, right? And 1 atm is equal to 1.01 into 10 to the power 5 Newton per meter square. So just convert this atm in Newton per meter square. So it would be 100 into 1.01 into 10 to the power 5 Newton per meter square. Now just put the value in this equation. So P is 100 into 1.01 into 10 to the power 5 divided by 0.0098 divided by 100. So after calculating this, the answer would be 1.033 into 10 to the power 11 Newton per meter square. So the bulk modulus is this 1.033 into 10 to the power 11 Newton per meter square. So this is our answer. Question number 5. What increase in pressure will be needed to decrease the volume of 1 meter cube of water by 10 cc? The bulk modulus of water is 0.21 into 10 to the power 10 Newton per meter square. Okay. Now we know that bulk modulus K is equal to P divided by delta V by V. So from here, pressure is equal to K into delta V by V. Now here in this question, the volume is given. So volume, the given data are V is equal to 1 meter cube. Delta V is given, which is 10 cc. That means 10 cubic centimeter. Now here we have to convert this cc in meter cube because all the other units are in SI. So we know that 1 centimeter cube is equal to 10 to the power minus 6 meter cube. So here it is 10 into 10 to the power minus 6 meter cube, which is 10 to the power minus 5 meter cube. Then K is given. K is equal to 0.21 into 10 to the power 10 Newton per meter square. So after putting all the values, it would be 0.21 into 10 to the power 10. Delta V is 10 to the power minus 5 and V is 1. So two 2.1 into 10 to the power 4 Newton per meter square. So this is our answer. So the increase in pressure will be 2.1 into 10 to the power 4 Newton per meter square.